All right, yeah, let me make you a co-host. All right, yep, you should be able to share your screen now.
Okay. So I read the book and reread the book, and the only two it talks about is this first one, until the MySQL client application releases the connection by typing quit, or until the MySQL server closes the connection. Those are the two that I checked the first time I took the quiz, and I got it wrong. So then I thought, okay, well, some of the things have a slash, like /H for help and stuff. So I thought, well, maybe that's it, but I still have it wrong. So I have no idea because none of the other answers are in the book.
Let me pull it up here real quick. Make sure it's not bad.
And it's on the very first page of the chapter of the book.
I think I had the similar question.
Okay, so
I had the same question too.
Oh, good. Thank you, everyone.
So let's see. Okay, so it's basically asking the connection is active until what happens. And the first one, until the MySQL client application releases the connection by typing quit, is true. So you got that one. Till the second one, until the MySQL client application releases the connection by typing quit, parentheses, that's false. So that's accurate. Until the MySQL shell application releases the connection by typing /quit is true. And then the fourth, until the MySQL client application releases the connection by typing exit. So that one actually is true as well. So I think the only one you're missing is that fourth.
Okay, so it didn't say anything in the book about typing exit.
Okay.
So that's why I was lost.
That's a little surprising because that's actually, I'll be honest, I never type quit. I only type exit. So I'm surprised. Yeah, I'll do some checking in there. If it's not in the book, I'll give some leeway on that one.
Okay, thank you. And then the following MySQL client command lists you connect to MySQL Student DB database. I couldn't find this in the book, and I couldn't find it in our reading. So apparently it must be false. But can you tell me what about it is false? I would have used it anyway, but I didn't know what it's.
Yeah, so the only reason it's false is I think there has to be a space between the U and the student.
Oh, okay.
And we'll talk about this one here in just a second. I'll actually demo that just so we make sure we're all on the same page.
Okay. And I think the rest were fine, so.
Perfect.
Pairing mode.
All right.
Pairing mode even means.
And then I do have a question on this week's reading.
Okay.
Where it talks about if we have the book open, it's when it uses the not.
The not operator.
Operator.
Okay.
That's between. So what? Okay, yeah, back on page 70 and 69, I believe.
Okay.
So it says where not true or true and true. What I'm trying to figure out in this is when we say not, and then we do parentheses around criteria, no matter what that criteria is. Are we wanting everything in that criteria to be not true, or just the first thing listed in the criteria to be not true?
Let me find where you're looking here. Okay, so is this where you're talking right here?
Yep, yep.
Okay, so not basically whatever like was there before not, basically do the opposite of it, if that makes sense. So basically like completely reverses it. So what I like to do is I always like to just pretend not's not, I like to pretend not is not there. And so like I do like where first name is equal to Stephen or last name is equal to Young. So in that case, we're going to get people whose first name is Stephen or Young.
Correct.
But the minute we add the not, it does the opposite of that. So basically it's where first name is not Stephen or last name is not Young.
So everything in the parentheses, the not would apply to all of that that's within the parentheses.
Correct. Because see, and this is kind of what they're kind of showing here. If we have a true or a true, so like if we're looping through stuff, it's going to return false. So if it's Stephen or it's Young, it's going to return false. And otherwise, so here's the antiquated version of that. If it's false or false, it's then true. So if their name is not Stephen or their name is not Young, then it will return them. So I like to just think of it, whatever is normal without not, just do the complete opposite. And that's kind of what it's there for, I think. I mean, obviously I don't know because I didn't make it, but the only time I really use not, because most of the time I would say, you know, where first name does not equal Stephen or last name does not equal Young. The only real time I use not is with other operators like in, so I can say not in or not null. So those special kind of things, which we'll go over that just here in a minute. And then otherwise, the only time I use not is if and I'm glad you brought this up because the paper for this week is all about how to double check your results. A lot of times what I do when I write a query is I will actually get the opposite version of that query just to make sure my numbers match up. And so a lot of times I'll just go hurry and throw a not on a where clause just to make sure that, okay, I have all the records with Stephen and Young. Let me swap that to make sure that, you know, the opposite of that doesn't have any records that I want or whatever. So you can really quickly change that, if that makes sense.
Perfect. Thank you so much.
Yep. Does anyone else have anything that they want to go over quiz-wise or anything like that? All right. So this meeting's probably going to be a little bit quicker because we're going to just cover a few of those things that I think maybe are a little confusing or maybe that sounds like the book didn't cover too well. And then what we're going to do is since this week is a lot in review, because we did a lot of covering filtering last week, we're actually going to get a head start on week 4 because we have seen some joins already. So I kind of want to very briefly kind of introduce joins and the different types of joins. So maybe you can see them and kind of start to get it. And then next week we'll hit those really hard. But I like to be proactive just so that way it's a little bit easier. So the first one is I'm going to connect to my database using the command line. And we've seen this before, but I think one area of practice that probably doesn't get done quite as much because we usually come in here and now I can't remember. Oh, we go to home and we say start command line client. You know, we do this and it already prompts us for our password. So we don't have to actually enter the connection manually. So I kind of wanted to show that real quick because it is very important. So let's see here. So, and I guess while we're doing this, we'll talk about what the flags actually mean. So when we run MySQL like this, it's actually running a program on the back end. And when we run it plain, it tries to connect with the default user or whoever you're currently logged in as, which in my case is just Tanner Crook at localhost. Now I have my database, which all databases should, lock down with a password. So you can see that by default, it's saying, hey, I'm not going to let you in because you're not using a password. So we can see that it says using password is no. And so basically we can assume that means that we need to use a password. So I could just run MySQL-P because that is actually my username. Tanner Crook, all lowercase, no spaces, is my username. So I can actually just run MySQL-P. And what the -P means is that we are actually, the -P means that we want to use a password. And those are called flags. So when we say -P, it's saying, hey, just so you know, I'm going to use a password and I want you to prompt me for it. And the reason that we don't type the password out is because everything we do in a terminal is all logged. And so naturally, if we type the password or whatever we type here, like if I just say my password is hello, if I didn't mean to type that. My password is hello. Whatever we type here is going to be in clear text. People could go and find it. So obviously we don't want to type our password in clear text. And that's why we use -P, because then it prompts us for our password. And you'll notice, and this always confuses people. They say, when I type my password, it doesn't work. It's working. It just doesn't show it, because it doesn't have a way to, or whoever programmed it didn't make it show stars or anything like that, because it's all clear text. And that also would give away how many characters you're typing, which is probably the main reason why they don't do it. So that's why we do that. So if you wanted the full string, you would type MySQL-U and then your username, Tanner Crook, and then -P. And then my password is School Rocks. It's not a secret. So the converse of that, so like if you really wanted to, we could go like this. And it looks like they actually broke that, which is good. So you can see here the third parameter. In fact, let's just take a look at the man page. -help. Let's try man MySQL. We can actually look and see what all the different options are and how to use it with a good command line tip. If you ever don't know what you're doing, you can always type man and then the command. So we can see MySQL --user equals username --password and the DB name. Now we don't use --user because they're shortcuts, which should be defined later down here, where basically instead of typing --user, we can just say -u. So I am glad you brought that up. Let's quit out of there and let's go back here. So I'm actually going to use this so we can do some stuff. So let's play around with that not operator here for a minute before we jump into join. So just to show some of those, let's what's our tables here again? Let me get logged in here so we can use it. All right, let's take a look. Let's take a look at film. I like, we can play with some movies. So we have a film ID, title, description, release year, so on and so forth. Let's take a look. Let's see what our rating is. So let's select distinct rating from film. And when I do select a stinker rating from film, I'm looking to see what some of my options are here. So in this case, we have PGG. Here's some of our ratings. So we're going to use those ratings to write some queries. So I'm going to kind of just keep it poked right back there in the background so we can see what those ratings are. So we can play around with this not operator. So let's select the title and the rating from film. And let's say we want it where rating, we're looking for a good family movie for us all to watch. So let's say rating is in. We say, okay, we've got younger kids, so it can either be PG or G. We're trying to find a good movie tonight to watch as a family. So let's go ahead and run that. And here is our results. So we can watch these movies, and there's actually quite a list. So there's our list of movies and the rating, so on and so forth. So to show the not, this is my favorite use of the not, is if we wanted to find all the others. So let's say we're trying to find the movies that we don't want our kids to watch. We can very quickly get the inverse of that, which is instead of saying, oh, everything that is PG or G, let's find everything that's not PG or G. And so I use it a lot with the in clause, just because that's really the only way to say not in a list. Same thing with not null, which I'm sure we've seen quite a bit already in the book, because not null is kind of one of those things where often we look to find where things are not null because we only want full data sets. All right, so let's take a look at another example that's not, let's like one from the, because let's take a look at something similar to what the book had, because we use the in clause there, which is a little bit more realistic for the or. But let's say where rating is equal to PG or rating is equal to G. So this is going to get the same thing as the first one, all the PG and G movies. However, this is where we have to start getting tricky, because if I just put not here, we're still going to get G's, right? We're still going to get rated G movies because it only applies to this. So we're getting everything that's not PG or rating is equal to G. So the way that we can do that in the book is if we put these in parentheses, now not applies to the whole thing. So now we get everything that's not PG or G, just like we have up here. Does that make sense to everybody?
But I would say that the not in, hey, this is Bradley, the not in would be, you want to try to keep your code as short and sweet as possible, and utilize a not in versus a where not with parentheses, and having the opportunity for mistakes by putting multiple clauses.
Yep.
Yeah.
Yep. The shorter you can keep your code, the less you're going to confuse yourself, especially if you have to come back to it after like a year. You'll be like, wait a minute, what am I doing? So that's a great thought, and one that would be really good to maybe put, because in the paper we talk about making sure your data is accurate. What are some things we can do to ensure that we have proper data sets? Even something like that, keep your code simplified. Find ways to simplify your SQL is a big part of making sure that your stuff's accurate. Because now mentally, we say, oh, it's not in this list. That's pretty easy mentally to parse, versus trying to determine, especially if you're beginning, not rating equals PG or rating equals G, that kind of thing. So yeah, you're dead on. The shorter you can keep your code, the better. Now, sometimes it's not as simple as, this, because in this case, we can say, oh, rating's not in this, but sometimes we have to do two things. So we can say length is greater than I don't even know what's in length. Okay, yeah. So we can say we want to find movies. I'm guessing that's in minutes. So we want to find one that's over, let's see, let's say over 100 minutes. So in this case, the only way to get this data set is to use not with the parentheses, because otherwise, because if we did it this way, we can only compare that with one column because the in works only with one column. But yeah, we want to keep code as simplified as possible, but it's also, we sometimes we have to, sometimes we just got to do what we got to do. Does that make sense to everybody? Does not make a little bit more sense?
Yes.
Perfect. Yeah, and I like it because I can really quickly change back and forth to get the exact opposite effect. That's kind of the way I like to think of not. Whatever I'm doing, if I add not, it does the opposite. So as far as the true and false, if it returned true before, it's going to return false. All right. Any other filtering stuff that people wanted to go over? Because that's kind of the topic of the week is filtering. So if there's something that you guys wanted to go over as far as filtering goes, we can cover that. If not, we'll jump into multiple table queries, which we kind of touched on this a little as well. But now we're going to start hitting a little bit deeper. So
Can I just throw one question out there?
Yep.
I don't believe I saw anything in the book, but are we able to use some of the commands such as exclamation equal instead of using not, or is it better to just
yeah, so that's why I say not. I don't use not very regularly. Like I said, the only time I really use not is in cases like this right here, or not null.
And we're the creators of the popular webcomics.
Normally I go like this.
Great, thank you. That was my answer.
Yeah, that's really what I do most of the time, because yeah, to me this is just it's easier for me to read. So
I'm so used to seeing it and using it in Java that I'm like, well, it doesn't make sense to do that in SQL.
Yeah.
So thank you.
Yep, no problem. All right, so let's jump into joins. Now, I'm going to try and be brief because obviously this section is actually for next week. So I'm just trying to give you guys a little bit of heads up so you can get your mind thinking. So maybe when you start your reading, you maybe already have some foundation of understanding, and hopefully it's a little easier. One of my favorite resources of all time as far as joins go is this little picture right here. I love this thing because whenever I'm querying from multiple tables, I always like to think of these Venn diagrams, and it literally it'll save you every time. So the bread and butter join is this one right here in the middle, and it's called an inner join. So if we were going to join between two tables, so let's say we wanted to join between, let's see, what's a good one. Let's see what's in city and country. Describe city. Okay, so if we want to get a list of city and country, we're going to have to join between two tables, because if I do select everything from city, we're going to notice that the country is a country ID. And the country ID doesn't mean anything. It's just a number right now. But we actually want to see like, okay, what country actually is this? That information is actually stored in the country table. So if we take a look at this, we can see here in city, we have the country ID. And then in country, we have country ID. And believe it or not, that's how those two connect. So if we see a 50 here, we can assume that when we say select everything from country, where country ID is equal to 50, that is going to be the country of Akishima. And I'm probably pushing, which is in Japan. So, and here we can see that Japan is country ID 50, and there's its information. And that's what makes these databases, the relational database systems, relational, is because every one of these tables is usually connected. And we've seen that with the ERD diagrams, you know, those webs with the tables all connecting, because we can see how the data is tied together. And so when we want to get that information back out, we need to do a join to connect the data, because most of the time we don't want to manually do this. We want the computer to do it for us. And essentially we're going to do it the exact same process we just did. You know, we're going to look in city and we're going to say, oh, what's your country ID? And then we're going to go to country and connect it based on the country IDs. We're just going to teach the computer how to do it for us. Now, in this case, table A is city, and then table B is country. So if we want the list of city and countries, we can do that way. Now, normally what I like to do, and this just takes a little bit of knowledge, if you want to be the most efficient, I usually like to start with the smallest table first. So in this case, country. So let's go ahead and do that. We're going to get the list of countries and cities. So let's select name from country. What's in country? Oh, it's just country. Okay. Select country from country. And if we run this, we're just going to get a list of countries. Pretty straightforward. Well, once we start to do our join, country is going to become table A. Now, if we do an inner join to city, city is going to become table B. So let's go ahead and put that in there. And it's pretty easy. We just say inner join city. And then we have to specify how we want to match it. And this is where our connection comes in, because we know that city has country ID and country has a country ID. So we're going to say city.country ID is equal to, or whoops, sorry, I got ahead of myself. Country.country ID, and technically you could do it either way, is equal to city.country ID. Just like that. And now we can run this and we're still going to get just the country. So now that we have a city connected, now we can get the city name. So let's go ahead and run that. And now you'll notice that we get the country and the city. And it all matches up just the way we want it to. Now, the key is what's the difference between an inner join, a left join, and a right join? And we're going to kind of take a look at this right now. If we look at our inner join, you'll notice that in our little Venn diagram, we have the intersection. So we're only going to get rows that have a match, right? So if I were to put another country in here, so let's take a look. I'm going to see if there's I'm sure there's United States of America. I'm going to make up my own country. So let's do a little game here on our left join. So I'm going to say insert into country, and let's do country. Yeah, let's just do country values, and we are going to insert. What's a good country name? For all you World of Warcraft fans, we're going to type in Eastern Kingdoms. So let's go ahead and run that up, and let's see if that has a default. Okay, yep. All right, so now let's make sure we got it in there. Just make sure we got that inserted in there. And there we go. So we have the Eastern Kingdoms. We just put that one in there. Now let's go back to our Venn diagram. And we're going to look at this. Now, if in this case, let's remember that we just put in a country for Eastern Kingdoms, which is table A. Now, we don't have any cities that are connected to Eastern Kingdoms. because we haven't inserted yet. We just barely put Eastern Kingdoms in there. So here's a little pop quiz, and feel free just to answer, throw it in chat. But if I were to run this query here that we just did, the inner join, am I going to see Eastern Kingdoms in the result?
No.
Okay. Yep. Perfect. We're getting no's. Yep. And that's absolutely right, because it doesn't have a city. And that's probably one of the biggest mistakes people make. Because a lot of times I think they just expect to see everything because, like, we're looking for country, city, and they expect to see it all there. And it doesn't, because we're doing an inner join. Now, the nice thing about an inner join, why I consider it, and I say it's the bread and butter join, because most of the time we want complete data sets, especially because I'm a data analytics person, so I do a lot of that. And so I don't want incomplete data sets, or if I am okay having an incomplete data set, I know beforehand that that's part of what I want, because most of the time we don't care about the non-matches. So, but sometimes we want it. So let's say we want all the countries and any cities that are associated with them. So we can use a left join to get those if we want it. So you can see the left join here is going to get everything from table A and the matches, but not everything from table B. So we're going to get all the countries, whether or not they have cities. So let's go ahead and do that. And it's just like the first one. So I'm actually going to take a copy of this. Actually, you know what? Let's not copy it. We're going to retype it, because we're going to use an alias this time, because the other thing I wanted to go over was table aliases. So we're going to select, we have two countries. So let's say co.country and cty.city from country co, left join city cty on co.country ID is equal to cty.country ID. So now when we run this one, we will see Eastern Kingdoms in here. So if we scroll down, technically we could have just wrote it, but we'll see all the results here along the way. Oh, I guess it'd be at the bottom. So there is our Eastern Kingdoms way down at the bottom. And you'll notice that under city, it says null. That's because there were no cities. So we can do it that way. Now, most of the time when we use left joins, we're trying to find everything out of something, but we can also use it to find places that don't have a match. So let's say we're cleaning up our data. Let's say that your boss comes to you and says, hey, we want to clean up our database. We know that we have some data in there that's kind of weird. One of the things we might want to do is let's see if there's any countries who don't have a city attached to them, because we can delete those. Maybe that country doesn't exist anymore. Maybe it was some historical one that we put a new name in for, something along those lines. So one nice thing about the left join, because we get everything from the left, if we want to find a non-match, all we have to do, in fact, let's go take a look here at our diagram. If we want to find all the countries that don't have a city, we perform a left join, but we just add where the key is null. So just like we did here, we saw it where a city is null. We can just say where city.cityid is null. And now all we get is Eastern Kingdoms, because it's the only country who doesn't have a city. Now let's take this one step further, and we're going to talk a little bit about the right join. Now the right join and the left join, I don't even know why I get why they both exist, but we're going to be really fast with this one, because the right join just flips the ordering, really. So the only difference between a left and the right join is the order in which you change your do your tables. Oh, and so David said, can you post the diagram? If you do a Google search for SQL joins on Google Images or DuckDuckGo Images, whatever you use, it'll be right there. It's in fact, that's what I do every time. I just Google SQL joins, and they're all right there. But I can post a link to it as well. So if we want to, let's say we did this the other way. Let's say we just swapped our ordering, right? So let's say instead of having country first, we had city, and then we said right join country CO. This is actually going to get the same thing. The only difference is we did a right join. So if we want to see all the countries, whether or not they have a match, sorry, I scrolled. We'll get that. We should still see Eastern Kingdoms down here. So right and left join do the same thing. You'll notice the only difference is that in the left join, picture your join as the middle. Whatever's on the left of this is table A, and whatever's below after it is table B. So here we can see that we just swapped it, because then we go, instead of going from country connect to city, we went from city connect to country. So if we want the same result, we just change that left join to a right join. Does that make sense to everybody? Left and right. Like I said, a lot of it just depends on their ordering. The only difference is just, this one comes first, this one comes second in your list of SQL. All right, and then let's talk about the cross join. And the cross join really comes in handy for certain things. So let's see, what's a good language? Let's use language. So let's take a look at the language. So in language, we have a name. That's pretty much it. So let's select everything from language. So we have English, Italian, Japanese, Mandarin, French, and German. And I'm guessing that will connect to film, because we have a language in each one of these. Let's take a look. Language ID, there we go. So basically that's a way that we can specify what language a film is in. So let's say that your boss comes and says, hey, we are going to create, let's say a new movie just came out, and let's think of a movie. Well, let's just say a new movie came out. A new movie came out, and he says we're going to have it in all languages: English, Italian, Japanese, Mandarin, French, and German. Now, in our database right now, we might have, because this language ID is in film, that means that if we have two languages, so like let's say English and Italian for what is a film? Let's pick one. Oh, there was a Cassidy, Wyoming, maybe. And was it title? Title, yep. I know there's one that said Wyoming, and that's where I'm at, so that's what we're going to use because it'll be easier for me to remember. All right, Super Wyoming. Let's use a Super Wyoming. And what is it? That is a super funny description for the movie, because we are nowhere near sharks here, nor pastry chefs. But anyway, Super Wyoming. So let's say Super Wyoming just came out, and we're going to have it in multiple languages. Now we can go here and we can actually see our language ID. We can see the original language ID is 5, which if we were to go and select everything from language, we could determine what that is, or we could write a join. Okay, so the original language was in French, but let's say that our boss comes to us and he says, "Hey, we want to make," and you'll notice the language ID here is null for all of these, which is really actually no language ID. Sorry, I was looking at the wrong column. Language ID was 1, which is English, and the original language ID is nothing. So let's say Super Wyoming, your boss comes in and says, "Hey, they just remade Super Wyoming in all the other languages that's in our database. And we want you to add the films for that so people can rent it." Now, instead of manually retyping everything, we can get clever. And I really like being clever because it saves time. And it's more accurate if we're clever. So what we're going to do is we're going to utilize a cross join because what's actually going to happen is we're going to have Super Wyoming listed multiple times for every language that we have. And that's just the way our database was designed because we only have a language ID per movie. So if we have Super Wyoming English edition, that's what we have in our database. But the minute we add Super Wyoming French, it's going to be another film, even though technically it's the same movie. It's different because the language ID. So what we're going to do is we're going to use a cross join. So we're going to select everything for right now, and let's say f dot everything. So we're going to select f dot everything from film, and we're going to call it f. And then we're going to get smart, and we're going to cross join that with language L. Now, if we take a look at our joins here, you'll notice that there isn't a cross join on here. And that's because a cross join doesn't really work with the Venn diagrams because actually the cross join is A times B. And I'm going to put that right in here in a comment. It's going to be A times B, which means we quite literally are going to multiply film by language. Now, in a large set like this, it would be hard to visualize. So we're just going to add a where clause. We're going to say where f dot title is equal to Super Wyoming. Right. So when we run this, we're actually going to get we're going to see the movie multiple times. Now, because of our where clause, we are only getting one record from film. So if A is film, we're having one result set and we're multiplying because it's a cross join. And there is 1, 2, 3, 4, 5, 6 languages. So we're going to have 6 in language. And that, if we do some simple math, is going to be 6. So we should get 6 records when we execute this query. So let's go ahead and run it. Check, make sure we're right. 1, 2, 3, 4, 5, 6. What do you know? And you'll notice that right now we have all the same information. But let's take this one step further and we're going to show you where the power comes in because we are going to, instead of just selecting everything from film, we're going to change this and we're going to select f dot title and l dot language name. Sorry. I kind of have some weird naming conventions in this database. So now we can see that we have fabricated a version of every language for this movie. So then we could then take this query and we could then use it to insert the data so we don't have to sit there and manually type it, which is really handy. So cross join is the Cartesian product or a multiplication of both tables. So if we were to, let's complicate this just a little bit more. Let's say all the Wyoming movies get multiple languages. Now, if we were just going to select all this so we can get our count, select everything from film where f dot title. So let's just see how many is in. Oh, instead of that, let's do a like. So we have three 3 Wyoming movies. So if we were going to do our math again, A times B, our first one is going to be 3. And we're going to multiply that by 6 because we're going to do that same thing. And let's go ahead and run this. Change this to a like. So 3 times 6, we should get 18 results. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there we go, which is perfect because now we have every movie in every language. Now, cross joins are one of those things that you don't use it all that often, except for utility stuff like this, which is really handy. Really, really handy. If you're ever fabricating data, and I like to call it fabricating data, if you're ever building data from existing data, which is usually the smartest thing you can do, because otherwise someone has to hand enter all this stuff. And that's something we don't want to do. So if you already have a portion of the information, a lot of times you can create it, even if it's in a custom table. Like, for example, if you didn't have a language table, make one because it's going to save you that much time. And then you can very quickly duplicate your data. Because I mean, in this case, we're dealing with 18 rows. But you can imagine if you're Facebook and you're rolling out some new feature and you're adding all these different options to users. I mean, you're talking trillions of rows that, is way easier to do this way. So anyways, that's a real brief on all these different joins that will hopefully help you get started.
Hey, can I ask you a question?
Yeah.
So this is Bradley again. So in that cross join, if for some reason one of those movies did not have a film, in essence, instead of 6 results for one of them, you would see 6 for one movie, 5 for another movie, 6 for another movie. Is that correct? Or would it display the null?
It would. So if we didn't have a film, the cross join
For language.
Yeah, basically, because if we didn't have a film, like let's say we were 1 film down, it would end up being 2 times 6, which would then just have less rows. So you'll always have results because it's going to take table A times table B. So if if an item in table A doesn't exist, you will lose all the 6 other languages, if that makes sense. Because basically, you're taking a multiplication. So you'll never have 5 for one movie because in this case, the cross join is almost raw math. It's just A times B.
Okay, thank you.
And if just to kind of show, if I were to take off this where clause and just run this plain, we're going to get a massive result set. But now we have every movie with every language. Like I said, I really use the cross join utility wise. All right, and I think we'll end it there. Next week, I'll show you how to do multiple tables and even self joins, because sometimes you might want to say, oh, I want to join country to country or film to film, something kind of crazy like that. So we can do a self join. In fact, we'll do some next week. I just kind of wanted to give you a taste of it so you can kind of see it and get an idea of how those joins work. Real quick before we go, though, 2 things that I really want to highlight to you, if you haven't seen them already in the book. When we talk about joins, really what it comes down to is primary and foreign key combinations. So if we take our country here, for example, with city, country has a primary key of country ID. And the primary key is that one that's pretty much always at the beginning of the table. And it's pretty easy to spot because usually it's the table name _ID, or it's just ID. And that's that one. I always like to equate it to if we open up a Excel spreadsheet, on the left-hand side, the thing we can't change is just the 1, 2, 3, 4, 5, 6. That's kind of what the primary key is. Your A, B, C, D, E, F on the top is your columns, and then the 1, 2, 3, 4, those are your primary keys. Now we have a little bit more flexibility with databases because we can kind of customize our primary key versus Excel, but that's how I like to think of it. That's a primary key. It never changes. You know, so if I were to select, let's add the country ID here. If I were to add country ID here, no matter what I do to that country, I can change its name. I can change its, gotta put the table name in there. I can change its name. I can change everything. But as long as I don't touch that primary key, which you don't ever want to touch the primary key, it will always be country ID 1. And that's kind of the key to these databases, because when we tie these together, we want to tie it to something permanent. Because you can imagine that if we tied it based on the name, like let's say Afghanistan changed their name for whatever reason, you know, all of a sudden, all my cities that were once tied to Afghanistan no longer have a match. So that's why we want to tie to something that's permanent, like the primary key. Now, if we take a look in city, we have a country ID in there as well. And in this case, and this is how I like to think about it, it's foreign to the city table. You know, does a country belong in city? Does country data belong in city? And the answer is no, because the whole idea of relational databases in design is that you want to simplify all of your data. So if we're talking about city table, we only want city data in there. We want to avoid duplication, because you can consider the following. If we had somebody's name, like let's say we had a person table and then an email table, we wouldn't want to put their email in person and in the email table, because then if they change their email, we have to change it twice, which we want to avoid that at all costs. So instead we link them. And so in city, country ID doesn't belong there. So it is foreign. And the only reason it exists is to connect city to country. And so basically, I like to think of it kind of like a connection or a door or a gateway. You know, if we want to get to country from city, we have to go through the foreign key or the country ID. We have to connect them, which is what we did right here. You know, we went from, if we want to get to, if we want to connect these two, we got to go through the primary key and the foreign key. And I like to think of those as a combination. Now, a lot of times they can connect to multiple. We'll get into more specifics, but always just think of it. If I want to connect this table to this table, I got to make a connection, and there's got to be something in common: primary key, foreign key. All right. You'll probably hit that in the book when you get to week 4, which I know is out there, but I just wanted to make sure that it's out on their minds. So that way, when you see it, it's like, oh yeah, we talked about that. And then the book will hopefully do a better job of explaining it than I did. So anyways, unless you guys have a question that you don't want on the recording or something like that, feel free to jump off, but that's all I had. So thanks for coming. If you have a question, just let me know.
Thank you, Brother Kirk.